Welcome to EPG Pathshala. I am Dr. Jaswinder Kumar, Assistant Professor, University Institute of Hotel and Tourism Management, Punjab University, Chandigarh. Today, we will discuss about the use of SPSS and other softwares in research, and after the completion of this module, you will be able to know about various types of softwares used in research and understand the relative advantages and disadvantages of these softwares. The present age is a data age where the use of statistical or data analysis softwares is inevitable. If we talk about any research field, these softwares are very widely used, and right software tool or platform is a strategic issue for research and development. In many cases, decision makers do not pay the right attention to a comprehensive and appropriate evaluation of what the market offers. Indeed, the choice still depends on few factors like, for instance, researchers' personal inclination, for example, which software have been used at the university or any research department. This is not wrong in principle, but in some cases it's not enough at all and might lead to a decision or situation which is not good for researcher in terms of investments or in terms of results required. Thus, everyone who regularly performs statistical analysis has to prefer a software option. It may of course be a combination of tools, but nonetheless, we have to see the preferences in terms of the accuracy, the ease of handling, and the variety of analysis tools available. In the exercise of determining a software preference, it is very important to understand its performance in terms of accessibility, in terms of analysis, in terms of result outputs as per the requirement. Depending upon these issues, the researcher should identify the merits, the accessible options, and other related factors while identifying a particular research software. It is generally acknowledged that the most important changes in the statistics in the last 50 years are driven by technology, more specifically by the development and universal availability of fast computers and of devices to collect and store ever increasing amounts of data. Satellite remote sensing, large scale sensor networks, continuous environmental monitoring, medical imaging, microarrays, the various genomes, and computerized surveys have not just created a need for the new statistical technology or techniques. Dear students, satellite remote sensing, large scale sensor networks, continuous environmental monitoring, medical imaging, microarrays, the various genomes, and computerized surveys have not just created a need for statistical techniques, but also created variety of computer softwares which has eased the data analysis techniques. The development of statistical software has become more and more important in last decades. Large data sets also create new problems of their own. In the early days, in which variety of tests were used in various research papers and publications, the analysis did not take much effort. In fact, it was usually enough to provide the values of a small number of sufficient statistics with the help of computer softwares. The large data sets require a greater deal of manipulation before they are ready for analysis, and the more complicated data analysis techniques often use special purpose softwares and some tuning. This makes reproducibility a very significant problem. There is no science without replication, and the weakest form of replication is that two scientists analyzing the same data should arrive at the same results. Dear students, we have variety of statistical softwares nowadays. We will discuss them one by one. First of all, we will talk about SPSS. SPSS stands for Statistical Package for the Social Sciences. It is general statistical software tailored to the needs of social scientists and the general public. Compared to other software, it is more intuitive and easier to learn. The trade-off is less flexibility and fewer options in advanced statistics than some other statistical softwares like S+, R, and SAS. SPSS is good for organizing and analyzing data. You can rearrange data, calculate new data, and conduct a variety of statistical analysis. Theoretically, there is no limit to the size of data files, so you can work on large data files in SPSS when you cannot do so in Excel. This version also allows easy input-output management, such as exchanging files with other softwares, changing the appearance of output, or cutting and pasting into different programs. SPSS allows the input of Excel data files. The best way to learn how to use SPSS is to work with it. Even if a researcher is not having a particular data of interest, SPSS provides a wide variety of data that researcher can play around with. The online tutorial under the Help menu in SPSS provides an opportunity to quickly go over basic features of SPSS. SPSS is a comprehensive system for analyzing variety of data. SPSS can take data from almost any type of files and use them to generate tabulated reports, charts, and plots, such as plots of distributions and trends, descriptive statistics, and complex statistical analysis. Statistical Package for Social Sciences, or SPSS, can perform high complex data manipulations and analysis with simple instructions. It is designed for both interactive and non-interactive uses. Good SPSS has scores of statistical and mathematical functions, scores statistical procedures, and a very flexible data handling capability. It can read data in almost any format, for example, numeric, alphanumeric, binary, dollar, date, time, and other formats. And the file created using spreadsheets or data or database softwares may be used. It also has excellent data manipulation utilities. SPSS also helps in a variety of functionalities such as data examination, data transformations, descriptive statistics, contingency tables, reliability tests, correlation, t-test, ANOVA, MANOVA, general linear model, regression, nonlinear regression, logistic regression, log linear regression, discriminant analysis, factor analysis, cluster analysis, multi-dimensional scaling, probit analysis, forecasting, time series, survival analysis, some non-parametric analysis, graphics, and graphical interface. SPSS is practical for entering data manually and editing data from various sources such as from online survey. SPSS allows for thorough exploration of data such as frequencies, means, distributions, correlations, etc. Extension programs such as AMOS enable comprehensive models of mechanisms of associations. However, there are certain disadvantages of SPSS. SPSS does not support structure equation modeling. By and large, an extension method of regression models based on covariance matrix. SPSS does not allow for simultaneous estimation of regression parameters and associations between independent variables, which are predictors. It does not provide model fit indices to evaluate how well data is represented. SPSS does not allow including latent traits without building composite scores or extracting factor regression scores. Let us discuss about Excel as a data analysis tool. Excel is Microsoft's popular spreadsheet software that enables the calculation and display of complex mathematical formulas. Extensive formatting is available to customize the viewing of these calculations as well. It imports data from a variety of sources. Internet Explorer adds new web discussion features that enable to take researchers' documents that have been saved as web pages and hold discussions on them, and even take advantage of interactivity that may be added to the web page. The web-based documents can then round-trip those documents back into Excel for editing using the familiar environment used to create the document in the first place. If you talk about the advantages of Excel, it usually installed on most of the computer users have at least some experiences with Excel. It is easy to use for data entry and data storage. Relatively, it is easy to use for basic descriptive statistics. Excel has some basic analysis tools built in, such as various tests like t-test, correlations, chi-square test. Excel has forms that can be set up for easy and consistent data entry. However, it has certain disadvantages, like Excel has no restriction on data type storage. For example, can enter dates inconsistently across entire data sheet. There is no simple way in Excel to include or exclude particular cases from an analysis without either deleting the data or making a copy of the numbers. Both bad practices, making it hard to review the work later on. In a nutshell, Excel allows multiple user errors to slip through the gaps. Access can be difficult to learn, particularly the way in which queries work. Excel also lacks facilities for calculating some simple descriptive statistics, for example, median or quartiles. Dear students, let us talk about another software for statistical analysis, that is OpenAPI. OpenAPI is a free web-based open source operating system independent series of programs for use in epidemiology, biostatistics, public health, medicine, and other various fields, providing a number of statistical tools for data summary. OpenAPI was developed in JavaScript and HTML and can be run in modern web browsers. The program can be run from the OpenAPI website or downloaded and run without a web connection. The source code and the documentation is downloadable and freely available for use by by other investigators. Open API has been reviewed both by media organizations and in research journals. The Open API developers have had extensive experience in the development and testing of API Info, a program developed by the Centers for Disease Control and Prevention and widely used around the world for data entry and analysis. OpenAPI was developed to perform analysis found in the DOS version of API Info modules, StatCalc and APITable to improve upon the types of analysis provided by these modules and to provide a number of tools and calculations not currently available in API Info. If you talk about OpenAPI advantages, OpenAPI has an online web browser based software interface. Therefore, no installation is required on the user's computer, and likewise, it will work under any operating system. It is open source software, so if researcher is really keen, they can see the calculation methods, although the understanding the programming code is little bit complex. This also means that if researcher wanted to download the OpenAPI code and build the own additions, they can do it. It has several quick and easy to use functions for some basic and intermediate tasks. Particular strengths include confidence intervals for proportions, 2 by 2 tables, including chi-square test and odd ratios or rate ratios, and as well for sample size calculations. However, the disadvantages are the flip side of the web-based format means that OpenAPI is restricted to relatively simple functions, usually based on pre-calculated summary statistics. Therefore, it is not a suitable tool for analyzing an entire data sheet. Next, statistical tools used is API Info. API Info is a public domain statistical software for epidemiology developed by Centers for Disease Control and Prevention (CDC) in Atlanta. API Info has been in existence for more than 20 years and is currently available for Microsoft Windows. The program allows for electronic survey creation, data entry and analysis. Within the analysis, the analytical routines include t-test, ANOVA, non-parametric statistics, cross-tabulations and stratification with estimates of odds ratios, risk ratios and risk differences, logistic regression that can be conditional and unconditional, survival analysis such as Kaplan-Meier and Cox proportional hazard, and analysis of complex survey data. The software is in the public domain, free and can be downloaded. The advantages: it is widely used in psychological and social science research. So some people will already have experience in using it. Good range of statistics from descriptive methods such as means, medians, frequencies, etc. through to common tests such as t-test, regression, ANOVA, and some more advanced statistical measures, for example, factor analysis. Most likely covers everything that researcher want to do himself. For many users, they might be consulting statistician for complex analysis. It can produce some nice looking graphs. However, it has also some disadvantages such as a few quirks here and there, but otherwise very user friendly and non-intimidating to people who are familiar with Excel. it can be a bit rigid with regards to advanced options for tests sometimes. It also lacks some of the more complex statistical procedures and data handling capabilities of the more advanced programs. Statistical Analysis System or SAS is a software suite developed by SAS Institute for Advanced Analytics, Multivariate Analysis, Business Intelligence, Data Management and Predictive Analysis and Predictive Analytics. SAS was developed at North Carolina State University from 1966 until 1976 when SAS Institute was incorporated. SAS was further developed in 1980s and 1990s with the addition of new statistical procedures, additional components and some related features. The advantages of SAS is that it is pretty much industry oriented and follow industry standards, widely used in medical research and pharmaceutical industry. It is well supported by consulting biostatisticians. It is very adept at data manipulation, for example, counting elapsed days between any two dates as well as analysis. Range of procedures from descriptive statistics through to simple analysis and on to complex analysis. It is usually good help for files with many worked examples available. It can write programs to automate some time-consuming processes. Researcher can save the analysis script files to keep track of what analysis researcher has actually done. So, it can amend or rerun it on later on. For those who are allergic to the text-based programming, there are some graphical user interface available that can help with analysis, although more complex tasks may only be possible through scripting. The disadvantages of SAS. SAS is a script-based programming system. There is a steep learning curve at the start, even for very simple analysis. It is essentially a programming language and can be tricky to get your head around and seems intimidating when a researcher starts using it. Let us discuss about another software, that is Stata. Stata is a general purpose statistical software package created in 1985 by Stata Corp. Most of its users work in research, especially in the field of economics, sociology, political science, biomedicine and epidemiology. Stata's capabilities include data management, statistical analysis, graphics, simulations, regression and custom programming. It has also a system to disseminate user-written programs that lets it grow continuously. The name Stata is syllabic abbreviation of the words statistics and data. There are 4 major builds of each versions of data. Stata/MP for multiprocessor computers including dual core and multi-core processors. Stata SE for large database. Stata IC, which is the standard version. Numerics by Stata supports any of the data size listed in an embedded environment. Small Stata, which was the smaller student version for educational purchase only, is no longer available. Let us talk about the advantages of Stata. It performs a large number of statistical analysis. It is easier to get to grips with than SAS in first instance. It has some quick to use commands that give results for simple questions quickly. It has a large amount of example data available within the package as well as online. Large number of downloadable extensions that can be used to do more complex analysis and data presentation. The main data files frequently updated to fix bugs and errors in the program. The disadvantages are files are frequently more than a little obscure. It is less flexible than SAS in terms of data manipulation. Main data files frequently updated to fix bugs and errors in the program. Dear students, let us talk about another statistical software that is called R. R is an open source programming language and software environment for statistical computing and graphics that is supported by the R Foundation for Statistical Computing. The R language is widely used among statisticians and data miners for developing statistical software and data analysis. The R's popularity has increased substantially in the recent years. R and its libraries implement a wide variety of statistical and graphical techniques, including linear and non-linear modeling, classical statistical test, time series analysis, classification, clustering, and others. R is easily extensible through functions and extensions, and the R community is noted for the active contributions in terms of packages. Many of the R's standard functions are written in R itself, which makes it easy for users to follow the algorithmic choices made. For computationally intensive tasks like C, C++, and Fortran code can be linked and called at runtime. Advanced users can write C, C++, Java, .NET or Python code to manipulate R objects directly. R is highly extensible through the use of user-submitted packages for specific functions or specific areas of study. Due to its S heritage, R has stronger object-oriented programming facilities than most statistical computing languages. Extending R is also eased by lexical scoping rules. Another strength of R is static graphics, which can produce publication quality graphs, including mathematical symbols. Dynamic and interactive graphics are available through additional packages. R has RD, its own latex-like documentation format, which is used to supply comprehensive documentation both online in a number of formats and in hard copy. The advantages of R. R is the most comprehensive statistical analysis package available. It incorporates all of the standard statistical tests, models and analysis, as well as providing a comprehensive language for managing and manipulating data. New technology and ideas often appear first in R. R is a programming language and environment developed for statistical analysis by practicing statisticians and researchers. It reflects well on a very competent community of computational statisticians. R is now maintained by a core team of various developers, including some very senior statisticians. R is a free and open source software, allowing anyone to use and, importantly, to modify it. R is licensed under the GNU General Public Licenses with copyrights held by the R Foundation for Statistical Computing. R has no license restrictions other than ensuring our freedom to use it at our own discretion, and so we can run it anywhere and at any time and even sell it under the conditions of the license. R has active user groups where questions can be asked and are often quickly responded to, often by the very people develop the environment, and getting support from the core of developers of R is a very positive support for the researchers. However, there are certain disadvantages. R has a steep learning curve, means it does take a while to get used to the power of R, but no steeper than for other statistical languages. R is not so easy to use for the new people. There are several simple to use graphical user interfaces for R that encompasses point and click interactions, but they generally do not have the polish of the commercial offerings. Documentation is sometimes patchy and terse and impenetrable to the non-statisticians. However, some very high standard books are increasingly popular to help the statisticians or learners to understand the techniques. The quality of some packages is less than perfect, although if a package is useful to many people, quickly evolve into a very robust product through collaborative efforts. R is a software application that many people freely devote their own time to developing. Problems are usually dealt with quickly on the open mailing list and bugs disappear with lightning speed. Users who do require it can purchase support from the number of vendors internationally. Researchers can use to enhance the statistical skills as well as to implement for variety of research projects. It may well be worth to the researcher to save the time to solve various complex problems. For getting the best advantage of statistical package, researchers should identify those packages that meet the needs and requirement of the researcher as well as which is fruitful for the researcher to reach to a certain conclusions or results which researcher wants to find out with the help of statistical packages. Thus, researcher should keep in mind that he or she should buy or work only for those statistical softwares with which he or she can conduct the data analysis and reach to the particular results or fulfill the requirements of research. Hope you all enjoyed this session. Thank you very much.